So we're told that a particle moves in a straight line, and it has this acceleration 6t plus 4 at any point in time. We're also told its initial velocity and its initial velocity and its initial displacement. Displacement is just its position. Where is it? At time 0, it's 9 centimeters away from the starting point in the positive direction. And so we're asked to find the position function for this particle. And so this is really just an application of taking antiderivatives. So we know that the derivative of the velocity is in fact the acceleration, which we're told is 6t plus 4. So now we can find that the velocity v of t is going to be an antiderivative of acceleration. So what? 6t squared over 2 plus 4t plus a c. Let's simplify this as 3t squared plus 4t plus c. But then we're told v of 0 is negative 6. And so just like before, I can say on the one hand, negative 6 is v of 0. On the other hand, v of 0 is 0 plus c. So this is just c. So I've got the velocity function, v of t, is going to be 3t squared plus 4t minus 6. Okay, maybe we'll circle that because that's helpful to know. But then let's realize that the velocity function is just s prime of t. So if I want to write down the position function s of t, I'm going to take the antiderivative of the velocity function. Let's just jump right to it. 3t squared, its antiderivative is just going to be t cubed, because when you divide by 3 they cancel, plus a 2t squared. I'm saying 4t squared over 2 is 2t squared minus a 6t plus another constant. I'm going to call it something else. I don't want to confuse myself by using c in 2 different ways, so let's call it d. And then I'm going to recognize that you're told that s of 0 is 9. So 9 is s of 0, which is, when you plug in 0, you get 0 plus 0 minus 0 plus d. So d is 9, and these have been pretty easy to solve. You haven't had to work too hard. So the point is s of t is t cubed plus 2t squared minus 6t plus 9. And that's what we were asked to find. This gives me, this equation gives me the position of the particle at time t. So we'll stop this video here, and we'll end this lecture with one more